This video is about factoring the difference and sum of two cubes. Turns out the difference of two cubes and the sum of two cubes are factorable. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. A cubed plus b cubed factors as a plus b times a squared minus a times b plus b squared. Now you need to memorize this formula, so let me show you a quick way for you to recall these formulas. For the first one, a cubed minus b cubed, how these factors? Well, for the first component, simply write whatever you get when you remove these exponents on the top. When you remove these exponents on the top, this will be a minus b, right? There you have the first component. For the second component, the big parentheses, you do this square of the first base, always first. Then you switch the sign. This is minus, you write plus. Multiplication of the bases at the center always. Then plus the square of the second base, always at the end. For the next formula, similarly, a cubed plus b cubed equal to whatever you get when you remove these two exponents, a plus b here, first component, multiply by a square of the first base, switch the sign, this is plus, you write minus, multiplication of the two bases in the middle always, plus the square of the second base in the end. Okay, so now that we know these formulas, let's look at examples. So let's see. For the difference of two cubes first. Example number 1 says factor x cubed minus 8. Solution. First, express this binomial as the difference of two cubes. The first term is a cube already, so we just copy x to the third. The second term is not, so we're going to express this 8 as the cube of some number. How we express 8 as the cube of some number? For that, advise construct a table of cubes. 1 cube, 1 times 1, 1 times 1, 1. 2 cube, 2 times 2, 4 times 2, 8. Here it is, the number 8, so 8 can be written as 2 cubed. So here we have the difference of two cubes, this form. So now we know that the difference of two cubes factors as the difference of the bases. Remember, whatever you get when you ignore these exponents on the top, multiply by the square of the first base, x squared. Notice x is playing the role of a, 2 is playing the role of b, so x squared first. Switch the sign, minus, then plus. Multiplication of the bases, x multiplied by 2. X multiplied by 2 is simply 2x. And then plus the square of the second base. Second base is 2, 2 squared, 2 times 2, 4. So we write 4 here. Then we are done. Now, you may say, hey, what about factoring this part? Turns out when you factor the difference of two cubes, this part is unfactorable, also known as prime polynomial. So don't worry about that. This is it. This is the final answer. Let's take a look at example number 2. This time they say factor 8x to the third minus 27. Again, solution. The idea is to express this binomial as the difference of two cubes. Since now I'm dealing not just with a variable, not just with a number, but number together with variable, advise write this way. Use parentheses this time. What should I write inside parentheses here so that when I cube it I get this guy? Well, for 8, 2 should be enough here, right? 2 to the third will be 8. For x, well, to the third, I should write just x here. X to the third will be this term. So now for 27, what number raised to the third power is 27? If we continue here with the table of cube numbers, the next should be 3 to the third power. 3 to the third power, 3 cube is 3 times 3, 9, times 3, 27, right? So here it is, so this should be 3 to the third. Now, once you have this form, the difference of two cubes, follow the formula. Formula says the difference of two cubes factors as the difference of the bases, right? The stuff that you get once you ignore this number 3 on the top, so 2x minus 3 times the square of the first base, the square of this guy. We're gonna write here 2x squared minus here plus here plus here. The multiplication of these two guys, 2x times 3, and then plus the square of the second base, 3 squared. Well, then just simplify. 2x minus 3 stays as 2x minus 3. 2x squared, 2 squared is 4. X squared, plus 2x times 3, 2 times 3, 6, 6x, plus 3 squared is just 9. Then we are done, right? Again, if you are worried about this guy, don't worry about that. This is unfactorable. This is it. This is the final answer. Because we are dealing with difference of cubes, right? Good. All right. Let's move on. Let's consider more examples. This time, let's consider examples for the sum of two cubes. The formula is here. Example 3, factor y cubed plus 64. Solution, again, express this binomial as the sum of two cubes first. This is already a cube, so just copy this as it is. This is not. We have to express this as the cube of some number. For that, advise construct the table of cubes. We did this before, right? Up to 3. So go as far as you need to go. So the next should be 4 to the third power. 4 times 4 is 16. 16 times 4, 64. So there it is. So 64 can be replaced by 4 to the third power. So we get this form. And we have a formula to factor this form. So the sum of two cubes factors as y plus 4. Remember, you write first whatever you get when you ignore these two exponents. So y plus 4 here. Then big parenthesis here. To fill this in, you start by squaring the first base, y squared. This is plus, you switch the sign to minus. Multiplication of the two bases, y times 4. Y times 4 is just 4y. And then you add the square of the second base, 4 squared. 4 squared, 4 times 4, 16, so it goes here. And then this is it. This is the final answer. Good. Example number 4 is a little bit different. This time it says factor completely. Factor completely 3x cubed plus 24. This word completely, remember, suggests that we should follow two methods of factorization. And the first method that you should try is always this. First, factor out the GCF. Remember, the GCF is the greatest common factor. So what is the greatest common factor for 3x cubed and 24? Well, for 3 and 24, the greatest number that goes into 3 and 24 is the number 3. I don't have to consider the variable because the variable appears only on the first term, not on the second. So greatest common factor is 3. So factoring out 3, we're going to get 3x cubed divided by 3. 3 divided by 3 is 1. We don't have to write a 1, so we'll get just x cubed plus plus. 24 divided by 3, 8. So we get x cubed plus 8. Now, since it says factor completely, we should continue factoring this part, x cubed plus 8. And indeed, we did this on example 1, right? So I'm going to just do it quickly. So second factor via sum of two cubes. Okay, so we express this guy x cubed plus 8 as x cubed plus 2 cubed. And then, well, we know that the sum of two cubes factors as the sum of the bases, right? Ignore the number 3's on the top. This is x plus 2 times the square of the first base, x squared. This is plus, switch it to minus. Multiplication of the bases, x times 2 is the same as 2x, plus the square of the second base, 2 squared. 2 squared, 2 times 2 is just 4. Then we are done. This is it.